Hi, this is Abdulaziz Khan, and now we are in the lecture number 13. So, as we are moving forward from diffraction, we are learning that how diffraction is created and how it is calculated, what kind of diffraction loss models path loss uses. So, now we are moving towards almost the end of diffraction. So we will just see, because as you remember from the last lecture, we see that the diffraction is a complex thing and it has some very complex mathematics involved. So there are some approximation for knife edge and for a smooth earth surface. And as we talked that the knife edge is mainly Daegu has worked on it a lot. But here we will just see some approximation, because I will also, as I always guide you, that for being a good planner, you have to have some idea. These approximation or this video will give you some idea that how you can interpret. Maybe you are not always 100% right whenever you say something, but you can at least starting interpreting the terrain. And for example, if you see a terrain, you can tell that if we go in this way, we may have this much problem. So let's go further. Let's see. So the knife edge approximation is basically, as I said, that the precise calculation of friction loss due to diffraction is very complex. That we know, the mathematics is not very easy. It's a differential math. You have to approximate a thing which is going up and down. So because it's a very complex function, so it is dependent on many things, like the frequency is the main thing, then the path geometry, and because it's diffraction, so how much dense is vegetation at some places. And as we don't have actual or accurate value, so usually we do some kind of approximation to understand that how things should be going. So now in this figure you can see some rough estimate. Don't take it as exact, but these are some rough approximate. And as we don't have only one Fresnel zone, for us the most important is the first Fresnel zone, but path loss calculates almost all the Fresnel zones, because the Fresnel zones will depend upon how much is the clearance between the ground and your direct incident ray. So just assume that if a knife edge is out of the Fresnel zone, it's almost touching, or it's a bit inside half of the lower Fresnel zone, then still you can approximate that it will not be any problem. It will almost like a zero loss because of this knife edge. But if the knife edge is very near to the main path, then as we know that the total energy is not going in a straight line, it's going in a Fresnel in the Fresnel zone type of thing. I mean, if you have seen the radiation pattern, then the pattern are also like a parabolic shape. So this half path, as we can understand, it's making the power available to be halved. I mean, half of the power is going, almost half power is not able to go. So almost 6 dB of loss may be added because of this. So if you are making a link which is very critical and you have to get the link somehow, then you should understand these values, that okay, if there is a knife edge type of path, then maybe it can make a 6 dB loss. If it is passing a bit higher, then it may be bringing a 12 dB loss. This again and again I'm saying this is approximation, these are not exact. So if it is fully stopping the first Fresnel zone, then you are almost 16 dB of your power may be lost. So what does it mean is that even if you have a knife edge and your line of sight is blocked, still because of some other, because we have after first we have second and third Fresnel zones, so still some power will be going and you will have a 16 dB loss as compared to a normal free of any knife edge link. So if it is a bit higher protruding out of your Fresnel zone, then maybe 20 dB of loss. Again, I'm saying that these are just approximate numbers. You should not say that this is bring exactly, because let me show you some practical terrains, because terrain are also not as simple. I mean, this illustration assumes that there's a knife edge of a very perfect shape and a very perfect place. But it may not be the same. I mean, it may be like for example, you see this path. Now this path has a knife edge type of thing in between, but even this knife edge has a small width here and a bigger width here. So maybe the first fresnel zone, or if your antenna comes a bit down, then it will be hitting this area. So the width of the area may be different. I mean, the exact shape of the knife edge may be different. But this is also to give you some idea that, okay, if you have this kind of terrain somehow, I mean, similar to this, then it should be, path loss should consider it more like a knife edge. We will see the other examples as well. But if we see as per this one, I mean, if we compare it to this illustration, we can see that almost more than half of the first fresnel zone is being affected. So we can assume that it will be bringing something in between. I mean, like between 0 to 6, like for example, 3, 4, or 5 dB of extra loss may be coming because of that. But we cannot say from our side. We have to run the path loss again and again, and we can check this. The other example I have is this kind of terrain. If you see this terrain, this can be considered as one knife edge. This is a second knife edge. This may be third knife edge, fourth knife edge, fifth, sixth, seventh, eighth, 9, 10, 11. So there are 12, 13 knife edge. And again, sometimes we are not very sure if we put path loss on its own approximation on auto, then even it can approximate this as a smooth surface, because there are too many knife edges. It will not be calculated by a Daegu method. It may be calculated by other methods. So sometimes we are not sure how path loss will be approximating the area. But if we want to force it, then we can force it that don't go to, for example, I can ask path loss that, okay, don't use the auto method, use the Daegu method, and just assume that 2, 3 of these, take it as the main values and use it. So there are, I mean, you can say there are many ways that this can be interpreted, but it's an example of knife edges as well. There are multiple knife edges. So the idea was to tell you that what kind of terrain can be considered in what way and what are the approximation in case of the knife edge. So I hope that this video should be beneficial for you and you should have learned something from it. So let's meet in some next video. Goodbye.